Okay, it's a series of complex numbers. The first topic is arithmetic and quadratic equations. Pretty straightforward little one. In number one, we're given that z, 2 doesn't it? Z equals 2 minus I, then z minus z conjugate all squared equals, and we have to work this out. Now, we need to know what the z conjugate is. Now, if we know that z equals 2 minus I, and the conjugate of z is equal to just 2 plus I. Just change the sign. So that was plus, this will be minus. So that's a pretty simple thing to do, isn't it? So z plus z conjugate is equal to 2 minus I plus 2 plus I. Of course, that gives me just 4. And 4 squared, obviously, is 16. That's simple. Done. Right, now, in number 2, we're given that z1 equals 2 plus I and z2 equals 2 minus I. We have to find out what z1 cubed minus z2 cubed is. Now, to do that, well, first of all, we'll factorise this. If you recall that z1 cubed minus z2 cubed will equal to z1 minus z2 times z1 squared plus z1 z2 plus z2 squared. Right, so z1 minus z2, that's pretty easy. It's going to be 2 plus I minus 2 minus I. And that's going to give me, the 2's will go out, and I'm going to get plus 2I here. Now, z1 squared is equal to 2 plus I all squared. So that'll be 4 plus twice the product plus 4I minus 1, which is 3 plus 4I. z2 squared equals 2 minus I all squared, which is 4 minus 4I. And when we squared this one, we're still going to get a minus 1. So minus 1, and it's going to be 3 minus 4I, the conjugate. Now z1, z2 is equal to 2 plus I times 2 minus I. It's going to give me 4, and that'll be a minus, but the minus I makes it a plus, so it's plus 1, so that gives me 5. So we need to put all this together. So that's going to be equal to z1 minus z2, this is 2I here. z1 squared is 3 plus 4I. z1, z2 is the 5. And z2 squared is 3 minus 4I. So it's 2I, and these go out, and that gives me 11, which gives me 22I. Here's the final answer. Done. Number 3. We have to find the square root of 8 plus 6I. What we'll do here, we'll let z squared equals 8 plus 6I. Now z is equal to x plus iy. So z squared is equal to 8x plus iy all squared, which gives me x squared plus 2xyi minus y squared. Now rearranging this, we have x squared minus y squared plus 2xyi. Now the real part of this is 8, so we can say that x squared minus y squared must equal 8. And we can say that the imaginary part, 2xy, must be equal to 6. In other words, xy must equal 3. So by just observation here, we can see that if x is 3 and y is 1, 3 times 1 is 3. So 3 times 1 will give me 3. And if we square this one, we'll get 9 minus 1 will also give me 8. So the solution is x equals 3 and y equals 1. But also, x could be equal to minus 3 and y could be equal to negative 1. So the solutions are that z, or the square root of 8 plus 6i is equal to 3 plus or minus 3 or plus or minus I. Or another way of writing it is plus or minus 3 plus I. Done.